Chapter 2, number 83. So 83 gives us information about a race between Laura and Helen. So probably most of it is really being careful about detailing it. So it says that Laura accelerates for 2 seconds and then travels some constant velocity for 8.4 seconds. And actually it tells us that the total time is just 10.4, but if they tell us this is 2, they're certainly indirectly telling us that that's 8.4 seconds. Helen does it a little different. She accelerates for 3 seconds and then travels at that constant velocity for 7.4 seconds. Because they do go 100 meters and they do actually tie. So what we're going to do is we're going to break these down. Let's look at Laura first. So just for Laura, she has some distance she's accelerating and then some distance she's traveling at a constant velocity, and we know that's equal to 100. If we think of the standard position equation, x equals x naught plus v naught t plus 1/2 at squared, she doesn't really have an initial position, she doesn't have an initial velocity, and so this first part, this first distance, is really just represented by 1/2 at squared. Okay, 1/2 a t squared, and we actually know that time, it's 2 seconds. The second distance, well, the second time around, she's not accelerating, she's just traveling at a constant velocity, and so we can say that it's x equals just vt. The tricky part is, how do you find the velocity that she's going at? Again, she starts here, she accelerates for 2 seconds, and then she travels a constant velocity for the rest of the 8.4 seconds. And that's where you think about the velocity equation. How do you figure out somebody's velocity? Well, you need to know how fast they're moving initially, but that's 0, and their acceleration rate, meaning how fast they're increasing their velocity in this case, and for how long. But we know that. We know that she accelerates for only 2 seconds. So we can say that her velocity can be written as a times that t1. Okay, so I guess to be careful, that really isn't a t1. So the beginning part, she's got a 1/2 at squared in acceleration distance, and then she's moving at some constant velocity. But that velocity is a times t1, and she does that constant velocity for some t2 distance, t2 time I mean. And that equals 100. And so at this point we know everything except the acceleration. 1/2 times the acceleration times 2 squared plus a times 2. Again, I don't know the final velocity she got to, but I know if the acceleration was a, that she got to a velocity of 2 times a, and that happened for 8.4 seconds, and that equals 100. At this point, the only variable left in this equation is a, and algebraically we can solve that and get something close to 5.31 meters per second squared. We can go back and find her top velocity or her constant velocity because we know that the velocity she got to was her acceleration rate for how long she accelerated. She started at 0. She increased her velocity by 5.31 meters per second for 2 seconds. And so for Laura, her top speed is 10.62 meters per second. Helen's calculation is exactly identical. She has a distance plus another distance to equaling 100. She's going to do a 3, and so she's going to have a 1/2 a times 3 seconds squared plus her acceleration rate times 3 seconds will give her constant velocity times 7.4 seconds, also equal 100. They run the same race and finish in the same amount of time. Her acceleration rate then is given by 3.745 meters per second every second, so meters per second squared, and giving her a top velocity of 11.235 meters per second. Okay, so again, they follow the exact same pattern. Laura accelerates faster, but for only 2 seconds, reaching a top speed of 10.62. Helen accelerates slower, but for a longer amount of time, and actually gets to a top speed. So if you think about who's winning the race, Laura is winning the race the whole way until the very end. Okay? I think part C asks, where are they at 6 seconds, or who's winning at 6 seconds and by how much. So really what we want to do here is think back to Laura. So again, this is Laura's x position. She does a 1/2 at squared piece, and then she has a v of constant velocity piece for her total distance. We know that acceleration rate is 5.31, and we know she does that for 2 seconds. And if we want to know where she is at 6 seconds, then realistically she's just going to be traveling that 10.62 meters per second for an additional 4 seconds. And so that gives us 53.1 is where she is located at 6 seconds. Now if we go Helen, and again, this was Helen on this side, Helen does the same thing. She accelerates for a certain amount of time, and then she travels at constant velocity for a certain amount of time. She has an acceleration rate of 3.745, and she does that for 3 seconds. And then again, if we want to know where she is at 6 seconds, she just has 11.235, her top speed, for an additional 3 seconds. And you figure out she's at 50.56 meters. And so it looks like that difference is about 2.54 meters. And right now, Laura's winning. And we kind of knew that already. Laura accelerated faster, reached her top speed really quick, and Helen was kind of catching her the whole time. Part D is the most challenging. So Part D asks, when and how big is the maximum distance that Laura is ahead? And you have to stop and think about this for a second. Laura's always going at greater velocity until Helen reaches what speed? Well, here's Laura's top speed right here, 10.62. Until Helen gets to this speed, Laura is not only winning, but she's pulling away. Once Helen reaches this speed, however, then at that moment they're going the same velocity, but after that, Helen keeps going faster and faster and faster. That's the period of time where Helen is actually catching Laura. So all we really need to do is think of the velocity equation. V equals V naught plus AT. And we want to know when Helen gets to this speed. So Helen started at 0. She accelerated at 3.745. And we want to know how long it takes for her to accelerate and get here. We know that her top speed is here. We're interested in when Helen actually gets to 10.62. So when you get that, you're going to get 2.83 seconds. So at 2.83 seconds, Helen has reached Laura's top speed. After that, Helen is going faster, and so Helen will then be catching Laura. And at 100 meters, they made the finish line. So the question is, where are they at? Well, we just did that calculation. We just did this right here. This is where Helen was at 6 seconds, or Laura and Helen at 6 seconds. So now we just need to do the same thing over again to figure out where Laura and Helen are at that time period. And what we said is that this time represents the maximum they're apart. So if you do that same thing, you'll find that Laura is at 19.43. That's how far she's gone in that 2.83 seconds. And Helen has only gone about 15 meters. And that's that maximum acceleration. So we're looking at 4.43 meters being the maximum amount that Laura is ahead. After that distance, Helen is going faster, and she continues to catch Laura the whole way.